Hi everyone, and welcome to our video on completely factoring 6 problems here. So depending on the number of terms decides the way that we factor. So when we factor, our first step is to always try to factor out a GCF if there is one. Okay, so we always do that first if it's there. So that's like our ones up here where we're able to factor out something from every single term. After that, we start to look at the number of terms left over. If there's 4 terms, we use a process called factor by grouping. 3 terms, there's all sorts of methods. So the AC method, divide to fix, the guess and check. This is often one of the main ones that we see, the 3 terms. So I'm put in more. Okay, so I'm going to cover maybe 1 or 2 of the methods. So if you do want to see more, look at some of the other YouTube videos on factoring because there's just so many of them. So if you do need more practice, you can find an abundance of factoring. Okay, and then if there's 2 terms, we usually check a difference of squares. So we'll see that there too. Okay, no matter what, check your answer because it's easier to multiply than it is to factor. All right, so let's factor. So our first one here, so I'm gonna put a little, actually let's color code it. I think that might be easier. Okay, so this has 4 terms. This has 4 terms. So the way that we're gonna factor this is to group. To group, we group the first 2 terms, and then we group the second 2 terms. And then we look to factor out their greatest common factor. Okay, so we look to find the GCF of each part. Okay, so there was no greatest common factor of all 4 terms. Okay, so that's usually our first step, but often the greatest common factor of all terms is 1, and then we move on to one of these methods. Okay, so in our grouping, we can group these first 2 terms, and we notice there's an x in common. So there's an x in common in both. So we would factor that out, and then we would be left with x plus y. And you can even check as you go. I'm going to erase this right here and here. But you can see x times x would be x squared. X times y would be xy. Okay, so we can see those and double check as we go. Okay, and then the second 2 terms, we can see, oh, there's a 5 in common. So we'll take that out. Now we choose the sign. Since they're both positive, I'm choosing a plus. If they have minuses involved, then we would have to maybe decide to do a plus or a minus. Okay, so, and we can again just check as we go in case we choose the wrong one. But if we take a 5 out, we would be left with x plus y. And then again, we can double check, that is good. Now that we factored the first 2 terms and the second 2 terms, we see, oh, these 2 terms in the big or that I'm highlighting are the same. So because they are the same, we can factor that out. So I'm going to keep that kind of highlighted and say, well, x plus y was the same in both of these terms. So the plus sign, this plus sign is separating the 2 terms. So x plus y in parentheses is counted as a single term currently, and we can factor it out. And then we're left with this x and that plus 5. So then we put those in parentheses, x plus 5. And then that's it. And then that is our factored. Now we should check. When we check it, we distribute. Okay, so x times x is x squared. X times 5 is 5x. This positive y multiplies the x to be xy, and then the positive y multiplies the 5 to be 5y. And then we can see, oh, the terms are the same. They're in a different order, but x squared is there, xy is there, 5x is here, and 5y is there. Okay, so with addition, you can move things around, so it is the same. So that means we did it correctly. Okay, our next one. Now this one, I'm going to star, these have 3 terms. So these are all going to be similar. All right, and we have different methods to do these problems. Now, usually the method I like to use is the guess and check method. Still, the very first step is to see if there's a GCF out of all the terms. In this number 2, there's nothing in common in all of them besides 1. And so then we move on to our next process. Okay, so all of these trinomials, so those have 3 terms in them. So like tricycle, 3 wheels, trinomials have 3 terms. So these are all going to factor in a similar way. I'm going to do the guess and check method because I know they always factor into 2 binomials. And so after that, my first thing is I'm looking at this y squared and I'm thinking, well, what times what gives me y squared? The only thing that times itself that gives me y squared would be y. And so I put that in the first part of each parentheses. Okay, so I know y times y is y squared. And then I go to this 44. Now the 44 has different ways to get 44. So the way that we can multiply to get 44. And I'm just making a factor tree to the side to see those options. So like 1 and 44 multiplies to give 44. I know 2 and 22 multiply to give 44. And I know 4 and 11 multiply to give 44. Okay, so I'm thinking, well, what combination of these can I put into these spots right here and here? And then afterwards check, so again, guess and check to see if I'm going to be correct. Well, because this has a leading coefficient of 1, what I can really do with these different pairs of factors is figure out the signs that would add up to be -7. Okay, so I'm looking at these pairs. Okay, so it's a little messy, but I'm going to put it right here. So I need the pair to add or subtract to make -7. And so looking at my pairs, well, and I choose the signs to make that happen. It looks like I should do a +4 and a -11 because that adds up to be -7. Okay, and then now that I have that pair, well, I know 4 times 11 is 44, so I'll put those signs right in there just like that. So I have y plus 4 times y minus 11. And then that should be it. And then we would check it. Okay, so when we check, the y would times the y to get y squared. Y would times -11 to give -11y. +4 would multiply y to be +4y. And then +4 would multiply -11 to be -44. Notice that these add up to be -7. So, or -7y. So we do have y squared minus 7y minus 44. So that's a match to what we started with. Okay, so let's try that method again with this number 3. So this time around, though, there is a greatest common factor among all the terms. Notice there's a 3 in common with all of the constant parts, the coefficients. And then notice there's an x in common with all the variable parts. So that means we'll factor that part out right away. Now let me kind of block that off. So we have 3x instantly factored out. And then we go through and just make our adjustments to the 3 terms. So if I took a 3 out and an x out of 3x cubed, I'd be left with x squared. And then minus, if I took 3 out of 9, well, I know 3 times 3 is 9. And then x getting taken out of x squared means I'm left with an x. And then minus, taking a 3 out of 54. All right, so maybe a little bit of scratch work. 3 goes into 5 once. And then 3 goes into 24 18 times. So we know we'd have minus 18 left over. And still, even here, so I'm again going to erase real quick, but if I multiply this back through those 3 terms, it is a match. Okay, so it shows that it would match the original expression. All right, however, now that we factored out that 3x, it just stays there. So we just keep it in the parentheses, and then our focus is where I'm bolding, we're factoring this. Okay, and so that is going to be set up the same way as the last problem. I'm just setting up parentheses, and I'm thinking, well, again, first, what times what gives me x squared? Well, I know x and x give me x squared, so I can put those right away right there. And then I'm looking at 18, and I'm thinking, well, what times what is 18? Again, I can make a factor tree if I need it. So 1 and 18, 2 and 9, 3 and 6. And then I can just start to plug in and guess and check. Or again, because I have a leading coefficient of 1, let me highlight that. Leading coefficient of 1 on this part right here. Again, our focus is only in that bolded parentheses. Let me make it even bolder. So my focus is only inside there. It looks like I could just try to find the pair that adds up to be -3, which is this pair. So it looks like I should do a +3 and a -6 to make that happen. And then I could just plug those in right there. And then that would be it. Okay, now when checking this, you'd want to check the binomials first. So the 3x would be last. So this is our check. And we would take the x and make it x squared. And then the x and -6, there's -6x. +3 and x is +3x. And +3 and -6 is -18. Okay, and then we would have the 3x still to the side. We can simplify inside those parentheses. We would have x squared minus 3x minus 18. Notice that matches the bolded parentheses. And then we would multiply the 3x back in, and it would match the original. Okay, so I'm going to skip that because I'm out of room, but it does match it. Okay, so let's see this number 4. It also has 3 terms. All right, so however, it doesn't have a greatest common factor other than 1. So there's nothing in common in all 3 terms. So now again, we just move on to the next step. Well, because it has 3 terms, if it factors, again, it's going to factor to have binomials. All right, so my first focus is, well, what times what is 2x squared? Well, the only way to get 2 is to have 2 and x and then just x. Okay, so 2x and x multiply to give me 2x squared. So I'm just, again, focusing on this. And then I want to figure out, well, I have a -3. I need to find the product that multiplies to give me -3. And there's only one option. It's 1 and 3. So here's the guess and check. So it's either plugging in 1 here and 3 here. I need to make the 3 negative, so that means I should do maybe a plus and a minus. Okay, so that's a guess. Okay, so I'm going to erase that again real quick. So guess and check method, because I only have a couple options, it's just messing with the signs. Or maybe it's putting the 3 here and the 1 here. And again, I just need to make sure I choose the correct signs. That's the checking part. Okay, so sometimes the guess and check can take a couple of tries. However, I think it is one of the better methods because it can be quick once you get used to it. And often they don't make the numbers too wild, so it doesn't take too many guesses. All right, so however many guesses it might take is fine. What I'm going to go with is, I think my initial guess was the right one, the +1 and the -3. And then now let's check. Okay, so the 2x times the x would be 2x squared. 2x times -3 is -6x. +1 times x is +x. +1 times -3 is -3. And then we can simplify. 2x squared minus 5x minus 3. Yep, that's a match. That is the same as up there. So everything's good. Okay, so that guess was correct. Now, if it wasn't correct, I would just erase and try again, or scratch it out and try again. Okay, so that's my main method. Again, you have these other ones too, the AC method or divide to fix or guess, or I did the guess and check. A lot of students like to do like this cross method. Okay, so that if you already are using that, I mean, that's fine. I'd say no matter what, make sure to check it. Okay, so usually the signs are what gets students just messing up those. So double check always with multiplication. All right, so whatever method you use is, I mean, I don't care how you factor. I'm just showing my way, the guess and check. All right, number 5 and 6. Number 5 and 6, those are two terms. So I guess I'll do a different color. Let's do those in green. Okay, so these are the two terms. Usually if there's two terms, it's this minus this in between the two terms, and then we can do the difference of squares. So the difference of squares means that it kind of factors the same way as our previous ones, where we know it's going to set up with two sets of parentheses. And then now I'm focused on, well, again, kind of what times what is x squared? Well, x into x is x squared. And then I'm focused on what times what is 81. Well, 9 times 9 is 81. And then we just have to make sure we switch the signs. It doesn't matter which one is first. So it could be like that instead. X minus 9 and x plus 9. So these are the same thing. So they are the same. So the order doesn't matter there. And they both are correct. Okay, so still check it. X times x is x squared. X times positive 9 is positive 9x. So I'm checking this one. And then negative 9 times x is negative 9x. And then negative 9 times positive 9 is, oops, I wrote almost a minus. There we go. Minus 81. Notice these two are the same but opposite. So that makes them 0. So we're left with just x squared minus 81. Okay, so it's the same as what we started with. Okay, so that's how you factor if it's two terms. Again, only if it's a minus. If it was x squared plus 81, that plus usually means it's not factorable. Okay, so so if they do that, I mean, that's fine. That means you don't have anything to do. So the problem would be done. But they don't do it too often. Okay, so majority of the time you see a minus. All right, and then this last one here, x to the 10th minus 121. Again, still the first step, so I didn't mention it on this, is to see if there's a greatest common factor between both terms. On this, there isn't, it's 1. Same deal with this one, the greatest common factor would be 1. So then we move on and we say, well, it probably factors the same way as what the other one just did. Still, I'm thinking, well, what times what is x to the 10th? Here's where we use the rules for powers. X to the 5th and x to the 5th would be x to the 10th. So it's just dividing the power by 2 to know the power that we would put in these parentheses. And then now I'm looking at, I see a minus. And so now I'm thinking, well, what times what is 121? Well, 11 and minus 11. There we go. And then that is it. Okay, and again, the order doesn't matter. I'm going to just box this one. One last check. So x to the 5th and x to the 5th, 5 plus 5 is 10. So that is x to the 10th. X to the 5th and minus 11 is minus 11 x to the 5th. Positive 11 times x to the 5th is 11x to the 5th, just like that. And then positive 11 and negative 11 is minus 121. Just like last time, these become 0. And it is the same as what we started with. Okay, so that's how we can factor. Okay, and so the video is kind of long, so it's close to 20 minutes, and we just did 6 problems. So if you do need more practice, though, again, tons of problems to try out on YouTube if you do need it. Majority of them are the 3 terms that we would see, and really the 2 terms. So this blue one is we'll see it every now and then, but the ones in the black ink and green ink are the ones that we see the most often. All right, anyway, I hope that helps. If you have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again next time.